Now from today we start paper second. So first we discuss about derivative. So in class 11 we studied limit. Limit is simply defined as approach of a variable towards the fixed point. So here if a is fixed point, if the approach of that variable from right to that fixed point, so we call that limit as x tends to a plus, that is a right hand limit. If the approach of that variable from left to that fixed point, then that limit we call x tends to a minus, that is a left hand limit. And if both these limit exist, then the limit of a function exists, we say. Now when we find the limit of function f of x with the help of this formula, f of x plus h minus f of x upon h, and limit h tends to 0, then this limit, if exists, is called derivative of function f with respect to x, and this derivative denoted by f dash of x. This formula is called first principal derivative. So using this we find the derivative of all the types of functions. So first we discuss here types of functions that we studied topic wise, because when we solve the problems are given topic wise, exponential form, logarithmic form. So we write first types of functions. First function, logarithmic function. Second function, trigonometric function. Third function, algebraic function. Fourth function, exponential function. And fifth function, constant function. Again, there will be some functions, even function, odd function, that we discuss later in integration chapter. So when function includes logarithmic value, then that function is logarithmic function. For example, f of x is equals to log x. Then trigonometric function, if the trigonometric function include in the function, or we can say if the function include trigonometric ratios, for example f of x is equals to sin x, then that is a trigonometric function. Here algebraic function, that means if the value in the form of x square plus 2x, if in base variable is there and in power constant, then that type of function we call algebraic function. And exponential function, in exponential function, a raised to the power x, e raised to the power x, when in base constant is there and in power variable is there, then that type of function we call exponential function. This e raised to the power x, we know that value of e, which is lies between 2 and 3. This a is constant. For example, we take 2 raised to the power x, 3 raised to the power x. These are the examples of exponential functions. Then constant function, if we say 5, if we consider here f of x equals to 5, this is constant function. So while solving the problem, we have to solve the problem topic wise. So first we know what is logarithmic function, trigonometric function, algebraic function, exponential function, and constant functions. So first we see the standard derivatives that we already proved using the first principle. So here we have to use that all the standard function. So from that standard function we will form the derivative for composite functions. So first we see, if y equals to f of x and this value of f of x or value of y is x raised to the power n, then this is algebraic form. When we have to differentiate this, we can write a derivative of y with respect to x as dy by dx. If instead of y, f of x is given, then we write the derivative of f of x as f dash of x and x raised to the power n into x raised to the power n minus 1. That means when we differentiate x raised to the power n, we have to take power in multiplication and reduce the power of that variable by 1. So this is algebraic standard form. Then we have to find derivative of y is equal to f of x is equal to log x. So we write y by dy by dx, f of x by f dash of x, and derivative of log x is 1 by x. So this is logarithmic function, derivative of standard logarithmic function. Then d by dx of sin x, d by dx of cos x, d by dx of tan x, d by dx of cot x, d by dx of sec x, and d by dx of cosec x. So for your avoiding confusion, we mark here first. So first we have to write the formulas in this form that we already discussed in trigonometric functions: sin, cos, tan, cot, sec, cosec. So while finding the derivative, we write here plus minus plus minus plus minus. That means derivative of sin x is always plus, because when we find the integration of this sign, we get minus value. So for avoiding confusion, you have to remember the formulas or derivative of these standard functions, trigonometric standard functions, in this form. So you have to write plus minus plus minus plus minus. So derivative of sin x is plus cos x, derivative of cos x is minus sin x, derivative of tan x is sec square x, derivative of cot x is minus cosec square x, derivative of sec x is sec x into tan x, and derivative of cosec x is minus cosec x into cot x. So here we use this concept: sin, cos, tan, cot, sec, cosec, sec, cosec. So we pair this sin with cos, cos with sin. Similarly, sec with cosec, cosec with sec, tan with cot, cot with sec. These are the opposites. When we make pair, we write sin with cosec, cos with sec, tan with cot. These are both opposite and pair form. So here just you have to remember plus minus plus minus plus minus. And one more, when derivative of tan is calculated, that is sec square x. So for that you remember the identity 1 plus tan square theta is equals to sec square theta. From that you can recall derivative of tan is sec square. Similarly, 1 plus cot square theta is equals to cosec square theta. So again from that you can remember derivative of cot is always in terms of cosec square. So in this way you remember these 6 standard trigonometric functions derivative. Then next we see the derivative of exponential functions. Exponential functions are a raised to the power x, e raised to the power x. So derivative of a raised to the power x is a raised to the power x into log a. Derivative of e raised to the power x is e raised to the power x into log e, and we know that log e is 1. So we write a derivative of e raised to the power x as e raised to the power x. Then derivative of inverse trigonometric functions. So d by dx of sin inverse x, d by dx of cos inverse x, d by dx of tan inverse x, d by dx of cot inverse x. Then last two are d by dx of sec inverse x, d by dx of cosec inverse x. Now here derivative of sin inverse x is 1 upon x under root 1 minus x square. So here While finding the derivative of sin inverse x, we write plus sign. While finding the derivative of cos inverse x, we write here minus sign. So minus 1 upon under root 1 minus x square. Then derivative of tan inverse x, 1 upon 1 plus x square. So here observe the derivatives. In sin inverse and cos inverse, derivative are same but signs are opposite. And terms in denominator are in root, but in tan inverse derivative, terms are not in root. So we write 1 upon 1 plus x square, and the derivative of cot inverse x is minus 1 upon 1 plus x square. That means if you know the derivative of sin inverse, you can find the derivative of cos inverse by changing its sign. So here derivative of tan inverse is 1 upon 1 plus x square, and derivative of cot inverse x is minus 1 upon 1 plus x square. Then we have to find derivative of sec inverse x, that is 1 upon x into under root x square minus 1. So again observe this, sin inverse is of the form 1 upon 1 minus x square. Here this root term is x square minus 1 and one additional variable, that is x. So we write here sec inverse x, derivative of sec inverse x as 1 upon x into under root x square minus 1. Then derivative of cosec inverse x is minus 1 upon x into under root x square minus 1. This all the derivatives we find in class 11 with the help of first principle. So here you have to remember in this way. Then next, derivative of constant function d by dx of k. Here k is constant. We differentiate constant k with respect to variable x. So derivative of constant is always 0. Then one more formula, d by dx of root x, that is 1 upon 2 root x. D by dx of 1 upon x, that is equals to minus 1 upon x square. Actually these two are of the form d by dx of x raised to the power n, that is n into x raised to the power n minus 1, because this root x can be written as d by dx of root x is equals to d by dx of x raised to the power 1 by 2. So by using this formula, we write this 1 by 2 in multiplication. We reduce the power of this variable x by 1. So 1 by 2 minus 1, we get 1 by 2. Here x raised to the power 1 by 2 minus 1. That means we write here minus 1 by 2. This power we reduce to plus form. So we have to write in denominator. So we write x raised to the power 1 by 2. So 1 by 2 into 1 upon this power 1 by 2 means root x. So we write 1 upon 2 root x. So this is algebraic form. Now this d by dx of 1 by x also. D by dx of the power of this variable x is 1. So if we write this in numerator, we write x raised to the power minus 1. So again we apply this formula. So we write power in multiplication and we reduce the power of that variable by minus 1. So we get minus 1 into x raised to the power minus 2. So we write minus 1 upon, when we write this x raised to the power minus 2 in denominator, we get x raised to the power plus 2. So we write derivative of 1 upon x as minus 1 upon x square. Then next topic, rules of differentiation. So while differentiating the function, we follow some rules. If two functions are in addition form, that means if y is equals to u plus v, then we differentiate this y equals to u plus v as dy by dx is equals to du by dx plus dv by dx. That means if two functions are in addition form, we differentiate that two functions separately. So first we differentiate function u plus, then we differentiate function v. Then if these two are in subtraction form, if y is equal to u minus v, then derivative we write as dy by dx is equal to du by dx minus dv by dx. Now these rules are very simple rules, but when we differentiate two functions are in product form, then we do not write this as dy by dx is equal to du by dx into dv by dx. This is wrong. So we have to use here product rule. So product rule is dy by dx is equal to first function into derivative of second plus second function into derivative of first. Or you can find derivative of second function first. So you can write here, you can differentiate first function du by dx into v plus first function into derivative of second. In this way also you get the same value, but you have to find derivative of any one function if that two functions are in product form. So we extend it. If y is equal to u into v into w, then we write dy by dx as u into v into dw by dx. That means we find the derivative of w only, plus u into w into dv by dx. That means we find only derivative of function v. Then v into w into du by dx. That means we find the derivative of u only. That means while differentiating, we differentiate only one function in one term. So we have to extend. If three functions are given, so you have to use this product rule for y equals to u into v as dy by dx equals to u into dv by dx plus v into dv by dx. That means first function into derivative of second plus second function into derivative of first function. Now when two functions are in quotient form, that is u by v form, then we differentiate this as dy by dx is equal to, first we have to take the function from denominator. So we write v into du by dx minus u into dv by dx upon square of denominator. So you have to use this rule, that is quotient rule. So don't write derivative of y as dy by dx is equal to du by dx upon dv by dx. So this is wrong. So you have to use this rule, that is quotient rule. So again you have to remember, don't write this as dy by dx is equals to, here we take denominator first. If you take numerator first, u into dv by dx minus v into du by dx upon v square, then it is wrong. Because here u into dv by dx at second position, we write at first position. So if you write in this form, you have to take minus sign common. So for that you use this concept. You have to write denominator function at product form first, then you have to find v into du by dx minus u into dv by dx upon v square. This is quotient rule. Now fifth rule, if y is equal to k into v, that means if with function, if constant is provided, so while differentiating this k into v, we write dy by dx is equal to k into derivative of variable, that is derivative of function v. So when single constant is given, d by dx of k is always 0, but when this constant is with any function, then we have to take that constant common and we have to differentiate the function. For example, d by dx of 5 into sin x. So while differentiating this 5 into sin x, we have to take this 5 before the derivative. So d by dx of sin x. So we write here 5 into derivative of sin x is cos x. So in this way, we have to apply the rule first, then differentiate the given functions.